All right, everyone, I have a few practice problems here that we can try, and this will help us go over some of the work and power problems that you might see on your exit tickets, but also on your quiz for energy. So let's start with number one. A light bulb uses 300 joules of energy in 4 seconds. How much power does the light bulb use? Use the guess method to show your work. So I'm going to zoom in a little bit on that problem there. And let's do number one. So the guess method. That means that we're going to have to write out all the numbers that we were given. We're going to write out our unknown. Then we're going to write down the equation, substitute, and solve. So let's start with what we're given. We're given 300 joules. 300 joules is an energy, especially in this case, it says 300 joules of energy. So we're going to say our energy is 300 joules. We also have a time of 4 seconds. And then it's asking us for power. So we have our knowns, or what was given, and then we have our unknown, which is power. And then the equation, and then this is usually the tricky part of solving any problem, is what equation do you use? So there's an equation that I gave you in the guided notes that says power is equal to energy, or sometimes a change in energy divided by time. All right, so that's our equation. So let's just plug in our numbers. We have power is equal to 300 divided by 4. And so if you do that, you get 75. And our units for power are watts. So when you think about a light bulb, you can think of like a 60-watt light bulb or a 75-watt light bulb. This is a 75-watt light bulb, which is a pretty common light bulb that you would find in a store. All right, let's move on to the next one, maybe a little bit trickier, number two. A bobsled team pushes a bobsled with a force of 1,700 newtons for 28 meters. After 5.5 seconds, they stop pushing and jump into the bobsled. How much power did the team produce as they pushed the bobsled? Use the guess method to show your work. So again, let's start with what we were given. So we were given a force. We were given a distance or displacement. We were given a time. And that's about it. And so it's asking for power. Okay, so power is the unknown. Okay, so let's think about what we know. Some equations that we know. We know that power is sometimes like the change in energy over time, or it's sometimes work over time. But that might be useful. And then we also know that work is force times displacement. So those are a couple of equations that we might use. So notice that what we could do is we can find the work first. Because we have force and we have displacement, we could find work first. And then once we find work and we know time, we can find power. So those are the equations that we're going to use. So first, let's start off with work is equal to force times distance. So for that one, we'll do work is equal to 1,700 times 28. And I can't do that off the top of my head, so I'm going to use a calculator. That's a big number. Okay, 47,600 joules of work. All right, now that I know that, I can find my power. Power is going to be work divided by time. So I'm going to go power is equal to 47,600 divided by 5.5 seconds. Again, I can't do that off the top of my head, so I'm just going to grab a calculator back. All right, 8,655. Let's just round it to that. And again, our units for power are watts. And that's it. So that one was a little bit trickier, but notice that we did what was given to us. what was our unknown, and then we looked at a couple of equations that we could use, a couple of equations that we were introduced to in the guided notes video. And then we were able to use two equations to find our missing number. First, we had to find work, and then after we found work, we were able to find power. Okay, let's try one more. So this one, we have a power lifter. So obviously power lifters have a lot of power. Okay, so let's look at some of the numbers that we were given. So a power lifter lifts a barbell from the ground up to their thigh, a displacement of 0.6 meters. The power lifter uses a force of 1,400 newtons and lifts the barbell in 0.25 seconds. What is the power lifter's power? All right, so let's write out what we were given. So we were given a displacement of 0.6 meters, a force of 1,400 newtons, and a time of 0.25 seconds. So, side note here, you might have noticed that this is a pretty realistic problem if you ever see powerlifting, especially in the Olympics. So you have to maybe lift a heavy barbell up a certain height, and sometimes those plates are pretty heavy. Some of those barbells are pretty heavy, but they can do it very quickly. So we're going to use the same strategy that we did last time. We have a very similar situation where we have three numbers and we're trying to find power. So let's write out the equations that we could use. So again, power could be work divided by time, and work is force times displacement. So let's start off with this one, right? So we'll do work is equal to force times displacement. So for us, work is going to be equal to 1,400 times 0.6. And using our calculator, so 840 joules. All right, so same thing as last time. Now we're going to use our power calculation. So power is work divided by time. And plugging in our numbers, we have 840 divided by 0.25. All right, so power is therefore going to be 840 divided by 0.25, 3,360. That's a lot of power. Again, our units are watts. That's it. So those are just some examples for how to solve some of these problems related to work and related to power. So hopefully this is useful. Hopefully it prepares you for any problems that you face, whether it's on exit tickets or on a quiz in the near future.